welcome back. We've just got back from Carding Mill Valley and we've collected the data for the width and the depth of the river and for the velocity. So the first part that you might be asked about was how reliable were the methods that we did, the data collection techniques that we did while at Carding Mill Valley. So when we were there, you could see that with the velocity, the cork got stuck, so that changed the accuracy of our results. So we overcome that by doing that 10 times. We're going to have a look what we can do with that data in a minute. And working out the width, as well as forgetting my ruler, but we managed with that. It's about the accuracy of using the equipment that we have. So when you measured from bank to bank, was it really 3 metres? Was it 3 metres and 20 centimetres? How reliable was our measuring? How reliable was the communication between me and the team when they're writing down the results? Okay, so we're back. So this was the information that we got when we were at the river. So I've just made it a bit briefer for you. Okay, so we 0 centimetres from bank to bank. So it was 0 and then the other side was 300 centimetres. So the width of the river was 300 centimetres. And the depth at 20 centimetre intervals was written down. So it was written down on a pre-drawn table. So it meant that that was really quick. It allowed us to be as accurate as possible and to have the data, so it's primary data because we're collecting it ourselves, and it was in a format now that we can use to analyse quite easily. Okay, so with that data, we're then going to use a graph. So I've drawn the graph here. Oh. So the top line here is the level of the water, the surface of the water. So the figures that we collected here then become negative numbers because they're going below the level of the water. Okay, so at 20 centimetres, it was 9 centimetres deep, so that's about there. 40 centimetres was 8, 60 centimetres was 12, etc, etc. Okay, so we can continue to do our crosses until we get to 300. And then we can join them up like that. So here we've now got a cross section of the river at Carding Mill Valley. So this shaded area now is the water. This is the river bed, okay, so we can't see that. We were dipping in our ruler at these 20 centimetre points here. So this is what we were measuring. So that's our depth. So we've got width at site 2 at the middle course was 300 centimetres, and the maximum depth there was about 34, so that's actually down there, wasn't it? Okay, so we've done that at our 3 sites. So I've got our 3 sites here. Site 1 was in the upper course, middle course and lower course. So what we can work out here, so our hypothesis, the river's getting wider as we go from the upper near the source and the lower near the mouth here. So we can see that actually the width of the river here was 300, was 350, was 400. So the width of the river is true. We've answered our hypothesis. The width of the river is getting wider at all of our sites. Okay. Then the depth. So the deepest part of the river here, 34, 45 and 70 here. So yeah, the depth of the river is getting deeper as we go from source to mouth. So it's getting wider and it's getting deeper. But there were some problems with measuring our data, that this isn't accurate enough because we were hitting stones every now and then. So the depth of the river isn't even from bank to bank. Okay, so actually maybe one of our lower readings might have been in the middle or the lower course if there was a big rock in the way when we were measuring. Okay, so it means we then we can use this data to work out the average depth. So we can add the 9, the 8, the 12, etc. Divide by how many times we've measured. So how many of these have we measured? To work out the average depth. So the average depth here, so could be, when we've added all that up, the average depth was round about 24 centimetres. the average depth here, when we add up all those depths, divide by the number that we've got, worked out to be about 42 centimetres, and the average depth here was about 62. So by working out the average, we've taken away the irregularities that are in there. So we can conclude then a little bit more reliable that it is indeed getting deeper, because the average depths there are getting deeper each time. Okay, so we've got our table, then we've drawn our cross sections, we've worked out the average. So we've got the width here, we've got the depth and the average depth. Now, I've only scribbled this down, this isn't good. So these are not reliable graphs, not on graph paper. I haven't labelled my axes and I haven't got titles. So we did that very well when we got back from Carding Mill Valley. This is just to jog your memory. Second then, we did the velocity, okay? So the velocity of the river, we tested 10 times how long it took the cork to travel 10 metres. So these are seconds over 10 metres. So the first test, we did 10 tests to even out our reliability. So on the first test, it took 9 seconds to travel 10 metres. The second time, 12 seconds to travel 10 metres. Third time, 18 seconds to travel 10 metres. That was the same 10 metres. And actually, when I look back at the film, it looks like that I wasn't standing in line with one of the poles. But that, go over there. But that didn't matter because that's why we did it 10 times. So I felt I was in line with the pole. But we've got some error in our calculating. That did it actually go for 10 metres? I'm not sure. Then the higher results here, the cork was getting stuck in some twigs, in some stones. So that was then affecting the reliability of our results. So the things that we then did when we got back to school with the velocity data, we worked out the average for each site. So we're going to add up all the times, we're going to divide by 10. So the average speed at location 2 here was round about 20 seconds. Okay, to go 10 metres. At site 1, the average maybe was a little bit slower. There was certainly lots more boulders in the way, so 15 seconds. And then in the lower course, site 3, the average was about 40 seconds. Okay, so once we've worked out the average, we need to say why was the average good. We could have done the mean, median or mode, so I've done the mean here. We need to know the fors and against each type of mean, median or mode in this case. And then how can we do it?